Good morning, all of you. Hope you are all are well and safe. Today is the first day of Navratri, so wishing you all of you very happy Navratri. Thank you for joining us for today's webinar. My name is Priyasnath Rathod, Assistant Professor in Chemical Engineering Department, PIT, Parul University. Today we are presenting the webinar on application of fluid dynamic gauging for the investigation of membrane fouling. I am pleased to introduce today's speaker, Dr. Upasna Balyan Madam. She has working experience 4 to 5 years and she is currently working as assistant professor at Guru Gobind University, Delhi. She is going to share her views on the application of fluid dynamic gauging because membrane is very important topic and part as a chemical engineer. Okay, so I hand over the session to Madam. Those who have any question, any query, they can ask me on my WhatsApp number, which is shown in this figure. And Madam, now you can start.
Okay, hello everyone. So I really appreciate Parul University's idea just to deliver the webinars on different topics. So I really appreciate the university first of all, and second, I would like to thank everybody who came here and listened to the new technologies and interested in the new topics. So today I'm going to tell you a little bit. I would like to deliver a little bit about the fluid dynamic gauging, what kind of equipment it is, and what why we are using it. So since before talking about this fluid dynamic gauging, we have to encounter lots of things regarding this, like membranes, and how we can use the cleaning process, how this cleaning process helps in our day-to-day lives, and how this fluid dynamic gauging helps in the improvement of the membrane technology. So when we are starting this webinar, I would like to give some introduction regarding this cleaning part, when because we are talking about the membranes. So let's start with the biorefineries. So so the purpose of this talk is to state the art of monitoring membrane fouling, very, very, very big issue in the membrane technology or membrane industries for the pressure-driven membrane process in the biorefinery applications. So when we are going to the biorefineries, so the concept of biorefinery has been put forward for the effective separation of the lignocellulosic materials for high value added production. So when we are using biomass is basically it came major source of the biomass are the forest. So we live in that country where we can found lots of forest, where we can found our major outsource, that is biomass, that is wood, you can say, which is a very important raw material for the various biomass feedstock. So when we are using biomass in terms of wheat, straw, pines, and lots of things, where pulp and paper industries, they are using biomass as just to recover the highly value added products. So this is the in the slide you can see sorry, in the slide you can see this is the biomass, and this is the biorefineries which used to convert these biomass into the valuable products. For example, if we talk about fuel, that means ethanol and biodiesel, which is used as a fuel in future perspectives, obviously. So we can use these biorefineries, and separation technology plays a very important role in that case. So we can say that membrane separation techniques has been widely used in various industries like water purification, food and beverages, pharmaceuticals, and biorefineries, obviously, for the purpose of purification and concentration. So we are using biomass, we are using that biomass for the separation purposes, and then we are going for the final product, which can be used for various things. Like you can see in the screen that solvents like acetone, butanol, these are the products of the biomass, by obtained from the biomass, and we can separate or purify or concentrate using the membranes. So here these are different. For example, we when we talk about jetropa, sugarcane juice, starch, these are the biofuels. These are the first generation biofuels, and these are the second generation biofuels. So this is the basic difference between the first generation and second generation. So today we will talk about this lignocellulosic biomass, which we can obtain from the wheat straws or rice straws and other things. And these chips, which are generally what happen in if we talk about pulp and paper industries, they generally use cellulosic part of this biomass for the, but generally it has lignin, cellulose, and hemicelluloses. So hemicelluloses combined with the lignin has some lignocellulosic biomass, which is just the wastage of the pulp and paper industries. So for the research purpose, what we do is we take this lignocellulosic biomass, which is a wastage material of pulp and paper industries. So first, pulp and paper industries took that cellulosic part from it, and then for the byproduct or for the wastage part, we took over from the industries and then further enhance the process just to extract the lignin and the hemicelluloses. Another objective is, now we have the lignocellulosic biomass in terms of wood chips. So what we do is the extraction. Extraction is another thing, that you have to extract these maximum kind of lignocellulose, means lignin or hemicellulose, from that wood chips. It's a big challenge. So what you do is to adopt that process of extraction, which is very feasible for the membrane point of view. You cannot use any kind of extraction process and then continuously fed that system into the membranes, because membranes are very delicate part. I assume that everybody of you know what are the membranes, but I will take just few minutes to talk about the membranes as well, so that you can easily understand this talk. This is we are talking about three processes of the membranes: microfiltration, ultrafiltration, and nanofiltration. So microfiltration and membrane, you can see there are lots of particles, high value added components, macromolecules, low molecular weight component. That means mixture of these components present in a feed. When you run the feed into or force the feed over the membrane of the microfiltration range, that means your suspended particles will remove through microfiltration, because the size range pressure is very low and the size range is greater than 1000 angstrom. So now another process for after microfiltration is ultrafiltration, which can remove the macromolecules but not the low molecular weight impurities and high value added components. And these high value added components can be removed through nanofiltration, because generally what happen in microfiltration, the pressure range, because membrane is a pressure driven process. So when we are talking about membranes, then we should talk about what kind of pressure you are using or you are applying over the surface of the membrane. So when there is a microfiltration, you cannot go beyond 40 psi. So the range of the microfiltration will stand from 40 psi, not more than that. On the other hand, ultrafiltration, which is another process of purification, so you can easily examine it by applying the pressure not beyond the 100 psi. That means 40 to 100 psi is the range for ultrafiltration. But on the other hand, when you're talking about nanofiltration, the range of the cutoff of the membrane depends, varies, as well as the pressure, it is very high. it go beyond 100 psi and tends up to 180 psi or 160 psi. This is a very high pressure the system can handle. You should have a very good pump who can operate at that particularly high pressure. So in that case, these are the technologies we are using. So in that purpose, in the you should have the feed which have minimum suspended particles, minimum macromolecules, so that you can recover most of the hemicelluloses or the lignocellulosic biomass, and further you can use for the concentration process. Now, this is just a rough idea about the membranes. So I'm assuming as you guys know about the membranes, if anybody has any query about the membrane, let me know. I will clear that also. So now, after this, there is another a big challenge comes, which is the extraction. So what kind of there are lots of extraction processes. So hot water extraction, supercritical fluid extraction, ultrasonic extraction, but they generally takes low value of feed. Now we are talking about on the industrial level. We are not talking about the laboratory level. So in that case, this is a process which is called as a steam explosion. You can see on the screen, this is the steam explosion unit which I worked upon. So here I will tell you how this steam explosion will work. Obviously, I'm using some feed, some wood chips in it, and then it will be exploded in terms of steam. So wood chips with high pressure steam followed by explosion to the atmospheric pressure. This is the basic idea or basic principle behind the steam explosion unit. The most important operational condition in steam explosion pre-treatment are time, temperature, chip size, wood chip size, what size of you are using, what temperature you're using, in which time, and also the pressure, what kind of pressure you are using. So how let's see how it works. I will explain one by one. So by the help of this video, I will explain how mild steam explosion will work. So let's this is the steam box which generally used to generate the steam, in which these are the pipes through which steam travels to the chamber from which wood chip should placed. So these are the steam pipes, and this is the open chamber. This is the steam, sorry. This is the steam explosion chamber. It is done by mistake, so just wait a second. This is a steam pipe into the steam. This is the open chamber is the steam explosion chamber, and this is the unit which we used to measure the temperature inside the chamber. So we are putting the wood chips and just checking that these are the wood chips of the same size. So we place this wood chips inside the chamber and then close the chamber. We know the temperature. We monitor by the temperature measurement technique, and then this chamber should be closed and closed with the help of these big wrenches. You can see. So now this should be very highly tightly closed, and you can start it with the help of this steam. You're just opening the feed, the steam pipes, just so that we can put inside the steam, and the time should be 20 minutes. So you are providing the pressure up to 7 bar, and then for the 20 minutes. Through this, you can open the steam inside the pipe, and so that it can travel to the chamber. And this is just the time I'm showing you, through which you can say after some time you can explode it by just covering your ears. And this is the sound you can see. And now this is the wood chips which are coming down from the chambers. These are the collection vessel through which you can collect the extract. See, with the help with some wood chips, basically the extract with the treated wood chips. So that was just an video just to show you how steam explosion will work. So I will go to the previous slide again. That was the equipment. Now you can easily relate what I want to say. This is the steam box. These are the pipes which travels the steam, which takes this steam to this chamber. This is the chamber in which we place the wood chips, and then close the vessel. And after that, you this is the wall through which you can turn it on, and steam will travel to the chamber. At particularly, this is the pressure gauge. You can see the pressure, and here we are saying that I put it the 7 bar pressure for 20 minutes. It is a predefined time which we got from the literature. Obviously, every scientist will follow the path of another one, so we can rely on the literature. So after this, after some time, after 20 minutes, you can use this button. This is the wall which you should be open, and there's a sound, there's exploded sound you can see. And this is the collection vessel, the orange color collection vessel from the down of the setup, which collect the treated wood chips along with some water. You can cloth filter it, just a cloth filter, so that you cannot remove some of the macromolecules or the suspended particles present inside the extract. So now you have extract. These are the wood chips. This is the steam explosion you did, and then this is the extract you found after the filtration. After just the cloth filtration, I am not using any kind of membrane or the filters or the Wattman just to filter the extract. So this is just a very common technique everybody is using for the extraction and the filtration. So this is nothing new inside it. So now another thing, this extract will go to the membrane filtration or the membrane purification. When this extract will go inside the membrane, so fouling is another it fouling it which became a significant problem for the membrane processes. And to avoid this fouling, various strategy has been adopted. For example, what kind of strategy I'm talking about? It is, you can use the chemical cleaning. Chemical cleaning in terms of you can use acid and base cleaning just to remove irreversible fouling, or some kind of irreversible fouling and the reversible fouling over the membranes. And another process is just to modify the membranes and which is, and you can also optimize the operating condition. What kind of operating conditions? Operating conditions, for example, you can enhance the pressure or the cross flow velocity, but generally they will not play a very significant role in removal of these fouling characteristics. So in order to correctly select or target improvements to any measure, we need to understand a detailed mechanistic understanding for the fouling process. So for that purpose, this is the pictorial representation of the fouling. So I have used the 0.8 membrane for your better understanding. I can say this is just the membrane. The first one, these are the membranes, fouled membranes. After run of the purification at two different pressure, 500 millibar and 1000 millibar. So there's a delicate membrane made up of cellulose acetate. So this membrane will after these are the pictures after the experiments, you can say after 8 hours of experiments. So there's a thick layer you can easily see through these pictures, and the permeate is more clear at high pressure. The one is your feed which you are injected inside the membrane, another is your permeate. When you are talking about the membranes, there are two parts. One is retentate, another is permeate. So permeate, it is what what you are getting after the purification. So yes, this is first 500 millibar per minute and this is 1000 millibar per minute. And these are the fouled membranes which are very difficult to examine the thickness of the layer, what kind of layer it has, and how do we remove the fouling. So when we talk about the fouling, in previous studies, I also follow that path, the Hermia's pole blocking model. If you have heard about these models, there are two type of foulings always occurs over the membrane surface. One is reversible fouling, another one is irreversible foulings. But Hermia explained four models or pore blocking of the membranes. Generally, membranes have some zigzag portion. So what you can say, there is a complete pore blocking, intermediate pore blocking, standard pore blocking, and after that there is a cake filtration. So when the cake is built up, that means all the membrane pores got blocked. So you cannot even work upon that. So how you can remove these pores? Obviously, after chemical cleaning, some reversible part can be removed, but most of the irreversible part cannot be removed by chemical cleaning. So you should know about the thickness so that you can vary your operating conditions and remove this fouling phenomena. Okay. So, in other words, you can say the mechanism, one of the key mechanism is the cake fouling. Its growth and physical properties very difficult to access. So, in that case, these fouling characteristics developed during the recovery of the extractive components will be investigated using FDG, fluid dynamic gauging, which is a very new technique. uh, Very less people are knowing about this technique, and very less people are going to work on it because it's a new thing. So this is the setup of fluid dynamic gauging. I will explain how this setup is, what kind of setup, because this technique is still under development, and it is can be used for to estimate the thickness of the fouling layer formed on the membrane surface, because our objective is just to find the thickness of the what kind of how much is the thickness of over the surface. So here you can see, just try to understand this is the membrane module. This rectangular chamber inside has the membrane. So we can place the flat sheet membrane in this, and after from the bottom you can collect the permeate, and the permeate continuously measured through this weighing scale, which is just automatic technique. This is a feed tank, this is a feed pump, and these pipes just for the collection of permeate as well as retentate, as it is a cross flow process. So this pump sucks the feed, and then they travel through this pipe and go inside this setup. And this will come through this pipe and go to the setup. This is the nozzle. You can see this is a probe, which is a FDG, fluid dynamic gauging. This is our FDG, and how it will help you to find the gauging technique, how it will find the thickness, that I will talk about it later. And then this is our gauge flow, this is our gauge pump, and this is our gauge flow, which is basically just to identify the thickness, helps us to identify the thickness of the fouling layer over the membrane surface. And now we will how this FDG. So FDG, I will explain the FDG, which is just FDG. It is performed by the use of non-contact probe. There is a probe. There is a nozzle, you can say, or a probe, which is just basically used to operate on the principle of pressure drop through the flow construction. So I will explain what kind of method it is. You can see from the from the bottom, there is a membrane. There is a membrane, black colored membrane, over which fouling layer develop. Over which fouling layer develop, and then there is a nozzle. You can say there is a nozzle through which is just come in contact with the fouling layer when we are applying the pressure. As much as pressure you are applying, there is a there is there is a sorry there is a layer which is developed through fouling. There's a membrane. When the membrane and the nozzle difference is H naught, which is a cleaned surface, cleaned membrane layer, and after that, after 4 hours or the 5 hours, there's a layer developed of which is known as the fouling layer, and the nozzle distance with that fouling layer is H, and the thickness will be the deposit layer thickness will be delta, which is just H naught minus H. So H naught is the location of the underlying membrane surface. So when you are applying the pressure, as well as when you are continuously there is a flow of the particles through the chamber, through the gauge, through or inside the probe, which is this is the probe. And then you can see, as this probe touches the surfaces of the fouling layer, there is a pressure drop. And when this pressure drop starts, that means that is the actual position of your fouling layer. So the constant gauge flow is withdrawn through the probe, which results in an incremental pressure drop over the probe when it is close to the surface. So this is the technique, which is not very difficult to understand, not very much advanced, to just a single thing, that you have this probe which is coming in contact with the fouling layer, and when it is coming to the contact with the fouling layer, there is a pressure drop in enhancement, which is a dp, and you can plot the graph of H naught by dt versus dp, which is your pressure. Inside through the software itself, it gives you the it's when you are monitoring the dp, every H naught by dt is monitored by the software, and it will give you the graph of the H naught by dt versus dp, which I will show how it looks like. So flux, when we are talking about I'm telling you about the membranes. So how do you know this is the fouling? This should be the stoppage of the fouling. So you can say flux plays a very important role in that case. Flux basically volume per unit time per unit area. So you have a fixed area and you are varying the time at two different pressures. As you can see that the pressure at flux is almost same. It's not as much as varying with two different pressures, but it's just to show you how this graph will look like, how this pre-treatment, when you're talking about the flux, it look like. So it is sorry, it is something this is just the flux decline behavior with respect to time. When you are talking about the time, flux continuously decreases with respect to time, which is your main objective, just to enhance the flux. When flux is higher, that means fouling is lower. When flux is low, that means you are not very going good with the fouling characteristics. So this is just the experimental measured pressure drop over the FDG. So yes, this is you can see the first is red, which is a pristine membrane. Pristine membrane is your pure water membrane, the fresh membrane. Yeah, I'm talking that is a pristine membrane. So you have to measure the fouling through FDG probe after 60 minutes of fouling. Then you can see there is not as such difference at low pressure, that is 500 millibar, but there is a big difference between the fouled and pristine membrane when you are talking about the high pressure 1 bar with the same membrane, 0.8 cellulose acetate membrane. So the difference between this pristine membrane and the fouled membrane is basically your thickness of the fouling layer. So our objective was clearly indicate, if you want to foul the membrane, you have to be a certain pressure, certain pressure and certain difference in the range of the membranes. Is just the microfiltration membranes I have given the example. You can also work upon the nanofiltration membranes or the ultrafiltration membranes. It totally depends upon the what kind of pump you're using, what is the pressure range of the pump, what how this pump will go at higher pressures, and how it will work upon. So this the thickness is significant, and this thickness is basically around 20 micrometers, and it varies. It depends definitely what kind of feed you are using inside the FDG probe. But remember, FDG probe is such delicate probe that you cannot use any kind of sludge material inside it, so that it can block the probe entrance, because basically it works on the flow constriction. It works on those characteristics which are very difficult to when you're using these techniques. The setup should be cleaned very much, thoroughly cleaned. Inside the pipes there should be no sludge formation, nothing inside, some kind of hemicellulose is parted, so that it can be it will be difficult to remove. So this is the flow diagram. You have taken the wood chips just for the better understanding. This is just in summary. This is the wood chips. You're using the steam explosion experiment, and then there's a Stex extract. The steam explosion extract. So I'm just giving the name in a short form. That is Stex extract, and that's Stex is traveling to the microfiltration membrane. So this is the permeate, and this is the retentate, and through which this is the thickness of the surface of the fouling layer, which is a very interesting factor to know. Yes, the thickness can be measured. First of all, when I was doing my PhDs on the membrane, so I was encountering these fouling things. So the thickness, which is not easy to measure, trust me, this is something which when you're using the membranes, the first thing comes is the fouling, how you can remove. If you cannot remove the fouling, but still you can measure the fouling layer, that is the another thing you can do. In that perspective, the challenges become less. And if you know the thickness, now this pressure develops this much thickness, which is quite obvious and which is acceptable. That means you can reuse the membrane. So the cost, to enhance the cost of the process and to make the process cost effective, this FDG technique plays a very important role. So yes, that is it. I think I should not talk too much about the FDG. It is something I should give you guys a chance to know about these FDG techniques. And if you have any queries, let me know so that I can clear these queries as soon as possible. Please, sir, I think I'm done with these slides.
Okay, madam.
Hmm.
So let me done. Your part is done.
Yes, I am done. I am just waiting for the queries so that I can answer these queries clearly.
Okay. Madam, one of the student is asking me that it is a completely novel work. So, is it possible to apply in any industry which they are
Yes.
dealing with the type of falling problem like GSCL?
Actually, in India, I think nobody is using this technique. But when you are talking outside India,
Hmm.
lots of people are using this technique in the laboratory level only. because this is a new technique.
Okay.
So industries are basically industries relies on the laboratories, on the researchers. So when the
Hmm.
researchers give their results in terms of the research papers, then only industry can apply. So there are few research papers on which industries are taking part. So since I was taking the wood chips from the pulp and paper industries, so
Okay.
now pulp and paper industries from where I have taken the wood chips, they're interested to go further with the FDG technique.
Okay, madam. From our department, very senior faculty,
Yes,
Dr. Priya madam asking question. I
yes.
just read it. What is the type of membrane used for wood extract from steam explosion, and what
Hmm.
specific components will be present in reject and permeate both?
Okay. There are two questions inside it. I will try to answer. First is you can use when you're using the lignocellulosic material, you can use polyether sulfone membranes, which is
Okay.
just the material from which it is making, and also the ultrafiltration and the microfiltration. Both processes can be used for the purification purpose. But when you're talking about steam explosion, it's just an extraction process when this when there are lots of suspended particles that are generally visible by the eyes, then you
Hmm.
can use the vacuum filtration after, followed by this when you're doing steam explosion, and then you can do the vacuum filtration so that your system will be feasible to work upon with the membranes. Now you're using polyether sulfone membranes, and then after that only another, sorry, I didn't remember the another question. Can you
Another
repeat?
question, yes, madam. What specific be
Huh.
present
Okay.
in reject and permeate both?
Okay. So our objective was to recover lignin or lignocellulosic material. And yes, around 40% of lignin is recovered through this process.
Hmm.
Out of that, 60% remains in the retentate. So in that purpose, retentate as well as permeate is useful for our for the study.
Hmm. Hmm. Okay, madam. Madam, second question, Priya madam asking that when conducting wood extraction at
Hmm.
larger or commercial scale, how to know when to run FDG probe?
How to?
I repeat the same question.
Yes.
In wood or commercial scale, how to
Mhm.
know when to run FDG probe?
Okay. So, for example, you're taking 10 liters of the feed.
Okay.
You extracted one one unit of steam explosion. You can run up to 4 liters. So that
Hmm.
means 4 liters of the extract can be collected through one stacks.
Hmm.
So if you are talking about the 10 liters, so I've collected 10 liters of a steam explosion extract, and you
Okay.
can run, you should have the 10-liter feed tank, and then you will foul the membrane just for 8 hours or 10 hours up to your requirement. So
Okay.
you will run the setup and let the system to be fouled, let the membrane to be fouled hours or 8 hours or 10 hours. You will ready to examine the fouling layer. Now you will run the FDG probe.
Okay, madam.
Yes,
Another question.
sure.
Can FDG be applied for larger membrane modules like spiral wound or vibrating e-regulating modules?
Uh, Not really. It can be, it is now successful for the flat
Larger
sheet,
membrane. Okay.
larger
Okay.
flat sheet membranes. But if you are talking about another modules, that is spiral wound or the vibrators, no, it is not. It is not as such, or it is not right to say it is not. But yet, still, it is in development. So
Okay,
it
madam.
is developed till to the flat sheet only. And after some time, obviously, you can run it with the spiral wound. It is not as much as a big challenge.
Okay. So this type of only applicable for pulp and paper for all like fertilizer.
Yes, I in the beginning of the presentation, I told that it can be worked with the pharmaceuticals, sludge formation, or
Yes.
metal removal, and obviously in the food industries, pharmaceuticals, everywhere. Where because fouling membrane is everywhere and fouling is everywhere.
Okay. Ma'am,
Yeah.
another question which is asked by one of the student because he's
Mhm.
I think he's in final that dialysis also we are considered as a membrane dialysis part.
Yes.
So that
Yes.
this particular thing or theory is applicable in that particular part is also. Is it possible?
Dialysis dialysis is another process of purification. When we
But
are talking about the
that
membrane,
for
that
the fouling of
generally focused on ultrafiltration, microfiltration, and nanofiltration. Because reverse osmosis and dialysis generally works on very, very high pressures. So in that case, you cannot afford that pump.
yes, yes.
Industries also cannot afford that pump who can easily work upon that thing.
Okay, madam. And I think last question and very what I should say that very important and informative question is that how to calibrate or recalibrate that probe what you are
Pro,
discussing.
yes. It's a very interesting question, I must say. Whoever asked it, I really appreciate.
Just ask me
Because,
this question.
uh-huh, because calibration of probe plays a very important role. When you're calibrating the probe, you have to be taken out all the samples from the setup, and then you will place the pure water inside it. When you are running, at each time you have to find out the height h naught over dt measurement with respect to dp, which is your pressure. So h
Mhm.
naught over dt, which I showed in the slide, and then with respect to dp, then you will have a different concentration with the pure water. And generally I used different salts for the for particular salt for the calibration part. Then you have taken the particular salt, and then you measure at different concentrations. Then you can easily calibrate. It's just the same process you're using with UV, you can say, for the
You
calibration process. Mhm.
okay, okay, madam. Madam, any other good topic in your mind for the students for the final year project? Because I a lot in this particular membrane. So can you suggest any good topic or any particular area which our student can pursue their final year project? Maybe it is a small terms of knowledge which is currently because I know you
If
are visiting so
mhm.
many institutes and you are working very good experience in this membrane part as far as I
it,
know.
it's just if we are
So
students
can
can work on the membrane modification right now in India. Lots of researchers are focused in the synthesis of the membranes.
yes, yes,
So if you can, because the setup is a problem for the
hmm,
universities, because every
yes,
so
madam.
nobody is ready to go for the funding for the research for the universities. And obviously this is a COVID era, so we should be very funding. So what I can suggest is just the modification of the membranes. If you can modify the membrane, you can easily remove or held on the fouling. So modifications like you can easily mold the membranes at with different kind of which are useful. Suppose I'm saying polyether sulfone, but the polyether sulfone coating is also difficult to identify. But also in Gujarat, you polyether sulfone membranes, we deliver the membrane from Permunix. Gujarat
Okay.
is a hub of the Permunix membranes. So everybody generally contact with the Permunix. So yes, the modifications is a very big challenge in the industry. So students can work upon the modifications of the
Modification
membranes.
rather than the synthesis of membrane.
Yes, they can work upon the modifications. They can use different coating for the materials, and if they have the successful coating, and they can easily contact with the buyers and other things who have the setup already have the setup. Suppose if they prepare the membrane and send the free samples of the prepared membrane to the industries, so they will really appreciate that work. Just an idea.
Okay, ma'am. So, thank you very much, madam. I would like to thank you for giving us interesting, informative, and enlightening session. We
Thank you so
hope
much, sir.
our
I
listeners,
really appreciate.
our students, and other viewers. Thank you so much for Parul University and technical staff, as well as head of the department, principal sir, and president sir. So, thank you very much. Okay, madam. Thank you.
Okay, thank you, sir. Bye bye.